Good afternoon, everyone. I'm Kavana, Marketing and PR at Messen Labs. Firstly, thank you for joining today's webinar on Altair's manufacturing solutions. So, as you all know, Messen Labs is a leading provider of simulation and analytics solutions in India and a trusted partner of Altair. Our mission is to help clients enhance efficiency and achieve excellence in their engineering projects by leveraging advanced simulation software and data analytics. So, now I would like to hand it over to Mr. Niklesh, our Senior Application Engineer, who will lead today's session. So we encourage you to drop any questions in the chat and we will address them at the end. Thank you. So now over to you, Niklesh.
Hello everyone. So, my name is Nikhilesh Prabhu, working with Meson Labs as a senior application engineer for structurals and manufacturing solutions. So, in this webinar, I'll be taking you through one of the manufacturing solutions named InspireCast. Before we move ahead, feel free to stop me in between if you have any queries or drop your queries in the chat box. Once the session is completed, I'll answer your queries. So, yeah, so before we move towards the product review, let us see what are the challenges we will face while we are manufacturing a product. So, manufacturing a component involves various challenges that can affect quality, efficiency, and cost. The first challenge is undertaking the market needs and the idea validations, which helps us to test the feasibility of the manufacturing the product according to the needs of the market by various new technologies. The next is the material selections, which will ensure the chosen material meets the design performance and cost requirements. The third one is the tooling and equipment. So this involves high initial cost for specialized tools and machineries, and also for the maintenance. So the next one is the production scalability and complex design, and finally the cost management and the quality control. So to overcome all these challenges, so Altair provides various manufacturing solutions which include Inspire Structures for structural analysis and optimization, Inspire Motion for all your multi-body dynamic solutions, and as well as for fluids we have CFD solutions as well. So, and when it comes for manufacturing solutions like casting, forming, extrusion, and additive manufacturing, so we have Inspire Cast for casting simulations, Inspire Form for stamping of sheet metal, Inspire Cast for the Inspire Extrude for the extrude solutions, and also Inspire Print 3D for additive manufacturing solutions. So you can explore all these tools if and when required for your use cases. So now let's move on to this webinar topic, that is Inspire Cast. So before we move, let's see what is casting. So casting is a manufacturing process that involves pouring a liquid metal into a mold and allowing it to solidify to take the desired shape. Then the solid part is removed from the mold. So when we move on to the advantages of the casting, so it has a very high flexibility. So casting can be used for both ferrous and non-ferrous materials. It is highly scalable, so can be used for both small and large scale productions, and also cost effectiveness. So casting can be cost effective due to reusable materials and inexpensive mold components. With the advantages, we will also have disadvantages. So after the casting process, the mold or component may contain defects like porosity, mold erosion, cold shards, and many more. So these defects may occur under various circumstances like air entrapment, uneven metal flow, and many more. To overcome these defects and provide a sustainable, good quality components before it moves for the mass production, Altair provides a tool to undergo virtual feasibility process. So Inspire Cast is the tool which will help you simulate the casting process and helps you to understand the feasibility of the component as well as the process. So why Inspire Cast? So Inspire Cast provides a comprehensive simulation driven design environment for manufacture of high quality metal castings. It is fast, easy, accurate and affordable framework for early casting feasibility and processes development. It helps you quick ramp up with minimal training. So it's the fastest growing casting simulation in the market with simple 5 steps process to develop the full project for optimizing the casting process. So Inspire Cast not just helps you to simulate or check the feasibility of the casting process, but also provides you a geometry creation capabilities to do minor changes in your model, so that you do not need to take it back to your CAD tool for making any changes. So this tool is very intuitive and easy to learn, and just one click for creation of geometry, core, molds and many more other components. And just by specifying the geometry, it can automatically create risers and provide full access for manual manipulations. So now let's see which are all types of casting process are supported by the Inspire Cast. So Inspire Cast supports 5 types of casting. The first one is the gravity casting, where a molten metal is poured into the die or mold cavity under gravity. So generally the sand casting is one of the most common casting processes, as it can be used to produce a variety of parts, for simple gears and pulleys to complex components such as automobile engines. The second one is the high pressure casting. So high pressure die casting uses a machine to inject molten metal into permanent metal dies under high pressure. It is a good technique for manufacturing complex parts with a high degree of accuracy, particularly lightweight parts with thin walls that require consistent dimensions. The next one is the low pressure casting. Low pressure die casting is another metal casting process generally used in situations that require high quality manufacturing. In low pressure casting, molten aluminum or any metal is slowly drawn into a metal mold or die through a riser tube while kept under constant and controlled pressure. So this process helps avoid oxidation, cold currents and air inclusions. So generally producing excellent surface finish and highly accurate dimensions. However, it is much slower and therefore more costly than high pressure die casting. And the fourth one is the investment casting. So it is a casting process in which the mold is created from a wax pattern covered by a ceramic mold. So when molten metal poured into the cavity, the wax melts and metal takes the desired shape. This kind of casting helps in the mass production of complex parts easily. And the final one is the gravity tilt pour casting. So gravity tilt pour casting is a permanent mold process where the mold is positioned horizontally and is gradually tilted upright during the filling process. So it is filled in a controlled manner with low turbulence and a moderate flow rate. So this technique compensates for the effect of free fall at the beginning of pouring process and helps you to avoid air inclusions. So since we understood the different types of casting processes supported by the Inspire Cast, now we will be in a dilemma on which casting process need to be used. So casting process can be chosen by 4 different variables. First one is the geometry, material used, surface finish and cost. So let's go to the variables one by one. So let's start with the first, that is geometry. So if you require to cast a complex, very high dimension tolerances and very thin sections, it may require costlier processes. So if you want high thickness with at least 0.125 inch, then we can use sand casting or low pressure die casting. For thin walled sections and complex components like transmission casing, we generally use high pressure or investment casting, where the thickness of the component walls can be less than 0.025 inch. Similarly, if you require high excellent quality tolerances, then you can use investment casting, high pressure die casting or low pressure die casting. And for moderate tolerances, you can choose gravity sand casting. So both, then the next, let's move on to the material selection. So here both ferrous and non-ferrous materials can be casted by using a permanent mold made from the steel. For non-ferrous, which will provide you a better surface finish and tolerances, but ferrous materials need to be casted using sand molds as they are prone to oxidation. If you look into the table, aluminum and magnesium can be casted with all the processes depending on the quality requirements. You can choose the process, and most of the materials can be easily casted using the gravity sand or investment casting. Moving to the third variable, that is the surface finish. So if you are looking for a smooth surface finish, then using die casting or investment casting will provide high quality. better tolerances cast components. If you are okay with just a casting with less surface finish, then sand casting is suitable. And finally, the last one is the cost. So sand casting contains less cost involved as the tooling cost is very low. No high-end machines are required here. While investment or other die castings have high tooling cost where you require high pressure or low pressure pumps or required to pour the molten metal into the cavity. At the first glance, a casting process might seem too pricey for the part you are designing, but a more expensive process could cut your total manufacturing costs in the end. The higher the volume, the more economical it becomes to front a high tooling cost for speedier casting processes. So moving on to the workflow involved in this Inspire cast, as I mentioned earlier, it's a 5-step process which involves select part, define gates, import or create components, set up the process and run the simulations. So in the first step, the user must import the CAD into the Inspire cast, specify the imported CAD as a part and specify which direction is the gravity for the flow of the molten metal. In the second step, you should specify the gates. So gate is nothing but defining the entry point for the flow of molten metal into the die cavity. So this gate can be manually created in the Inspire cast, or if you have already created a gate in the CAD file, you can specify the gate for the entry of the liquid. The third step, you can create or specify different components like risers, mold, cooling system, chiller, sleeves, overflow, etc. To define different parameters for different processes. Okay, once we set our model in the first step, we go for the setup process where we specify the casting process, which casting process we are utilizing, and by using the initial velocity or the final time, we can run the analysis. So finally, once we click on the run from the bottom, we can get different parameters and as well the results. Within a few minutes, the run will be completed and all the results like filling time, temperature, porosity will be available for you to test your simulation and the design of the model. So once the analysis is completed, you can review various results in two factors. The first is the filling results and second one is the solidification results. In the filling results, user can review results like temperature of the liquid, velocity at which it is entering into the mold cavity, the pressure of the molten liquid into the cavity, the filling time, airflow within the cavities, mold temperature, mold erosions, we can find it out, and many more. In solidification results, we can see the solidification time, microporosities, shrinkage, solid fractions, then Neomi criteria and more. So you can also animate and visualize these results in your model. So InspireCast is fast and reliable and has been tested and results have been verified experimentally and also with other tools and found the results are comparable. So with this, let's move on to the customer testimonials. So the first one is the Amazon. So it is a German-based agricultural machine manufacturer company. So who tells that who uses Altair InspireCast for manufacturing of their certain components, and they said that the durability of the casted components have been increased by a factor of 2.5 and the weight has been reduced by 8%, and their newly designed suspension component has reduced the manufacturing cost by 1/3. So with this, let's move on to the second customer review. It is from the Sido Druggers. So these are again one more German automotive component manufacturer which uses high pressure casting simulations by using the InspireCast. So with this, let's move on to the product demo and showcase how the Inspire tool works. So I have a small video which will represent you how this particular simulation works, and in the brief I'll explain you how the process works out. So Now, as you can see, this is how the user interface of the Inspire cast looks like. Now you can see that the model has been imported into the Inspire cast. So Inspire cast supports various types of models irrespective of the file format. Now you can see that as I mentioned in the step 1, so you just have to specify the cast part. So he has specified the cast part and also provided the material properties. Now he has selected the second step he has taken to showcase you how the in-gate has to be provided. So when you click on the surface, it will automatically create an in-gate for the entry of the molten liquid. You can specify your own in-gates. If you have already created, you can just specify that, or you can just create on your own in this particular user Inspire cast. Now you can also see that how he has run the basic setup. Just he has provided the filling time, and you can see that the simulation has run and the molten liquid is flowing inside this particular uh, cavity, the mold cavity. Now he has showing you how the different result types are available. Now as you see that there were certain errors when he was filling it. The molten liquid is cooling at a faster rate. So he's trying to increase the ingates. So you can provide multiple ingates for your molten metal to move inside. And also you can just provide different orientations for the flow of for the entry flow. Okay. Now you can see that how the liquid is flowing inside the model, and even though it is flowing as it reaches the right hand corner, you can see that it is cooling at a faster rate. So he's trying to manipulate this particular ingate and reanalyzing it. Now as you can see, now it is a pretty good flow of metal as the molten metal moves to the right hand corner of the model. It is not turning into blue, so it is trying to keep certain temperature. Okay, so now he is trying to open another model where the already runners and ingates are already formed. So if you have these kind of ingates or a runner created already, you can just import it, specify those materials as your runner, and you can just run the analysis by specifying the filling time for this particular analysis. So you can see how fast the analysis process works over here. It creates a imaginary mesh around that particular component, and then you can see how the metal flows inside the metal by using these runners. Yeah, you can use this particular animation tool to verify the flow of your model and understand how this particular flow takes to the model. Okay, so with this, let me just I'll just stop this particular video and I'll take you to the demo of the model in the Inspirecast. So give me a minute. I'll just stop my sharing for a bit. I'll just turn on my Inspirecast. Yeah, so I hope now you can visualize my screen. And now this is how the user interface of Inspire looks like. So as I was mentioning, there are a lot of file formats Inspire supports. So if you want to open a model, you can directly go to the import options. Okay, when you have any kind of native formats or any other file formats, it can easily import it into the Inspirecast, whether it's a CATIA file, NX Pro, SolidWorks, step file, NX CAD, any type of file formats, it can be imported into the Inspirecast. So for this, let me just take you to one of the demo model where I'll just show you how this particular gravity casting works. So now you can see that there is a component, piston, caliper of a two-wheeler bike or a four-wheeler vehicle. Okay, so I would be liking to cast this particular component. Now, as I was telling you about the five processes, the first process is to cast. Second is to provide the inlet for the metal to flow inside the cavity. The third one is the different types of components, whether you want to create a core, chiller, riser, sleeve, overflow, mold, cooler. If you want to provide any filters, if you are working with the high pressure casting, you need a short sleeve to pressurize the flow of the molten liquid into the mold cavity. Then if you are working with the tilt gravity, then you need a crucible where you need to tilt that particular casting cavity where the molten liquid gets filled into the cavity. And finally we have the stock for the low pressure, where you want to pressurize the liquid into the mold cavity. And finally we have the run option, the basic setup option, where you can specify which type of casting processes you want to use, whether it's a low pressure, high pressure, gravity process, you can specify it here. And finally you have the run option. Okay, so let me just go with the first step. I'll just specify my cast component here, select the component. I can specify a different components over here, different material properties. I can specify it here, or if you have to create your own material property, you can click on this particular window. It will take you to the my material options, where you can specify your material databases, or if you want any other components, you can easily take it up. Okay, so once I specify this particular component, I can specify what is the grade of the particular aluminum I need to select. I can select the grade. I can specify its temperature. Okay, and just click OK for the selection of this particular component. Now here you also have different unit system you can maintain with. So if you want to open with mm, kg, newton per second, you can also use that. Once the component once the cast component is provided, now you can directly go and specify the direction of the gravity for the liquid to flow. So now here you can see that it is showing it in a horizontal direction. Now I need it in a vertical direction, so I can easily click on the move manipulator tool, specify it with a degree, and either you can take it up or you can take it down. So you can just a minus symbol and it will showcase the gravity direction in a other way. So once this gravity has been provided, now you can directly go and create an ingot where the molten liquid must flow. So you can directly go and select the surface and it will automatically create the option for you. You have two options, a square and also the circular option, where the ingot needs to be provided. You can specify the dimension of that particular ingot and can close the factor. So once this particular gain gate has been provided, now you can directly go to the setup. If you want to create any risers, chillers, you can create it. If not, you can directly go to the basic setup. Yeah, here I need to create a core. If you want to create a sand core in this particular hole, you can directly click on the core. It will automatically detect those particular holes. You can select the core where you want to make it as a core. Specify the material of the core. You can see it as a silica sand or a green sand. You can specify. You can take it the temperature of that particular core, and you can see that the core has been created. Now you can directly go to the setup. You can take the filling time, or you can go with the initial velocity. So here I'll go with the initial velocity of 1 meter per second, and I'll just hit analyze. Now here in the analyze option, you have two different analysis types. If you want to visualize only the filling analysis, you can only see the results of the filling analysis. If you want to see also the solidification, how the component once the metal is poured into the cavity, how it will solidify. If you want to visualize those results, you can turn on the solidification analysis as well. And you can also specify your element size either by thickness or by the element size. Okay, once you provide this, you can just click on the run. So this will take around 2 to 3 minutes to run this particular analysis. First, it will undergo the meshing properties. It will try to mesh this particular entire component over here. and then it will do a filling analysis as well as the solidification analysis. You can also visualize the progress of this particular stages here. When you hover it over the particular status, you can see now there is a 10% progress has been completed. So still 90% of progress is remaining. So let's wait for 2 to 3 minutes till the process gets completed. Now you can see that the meshing stage has been completed for 100%. Okay, it is trying to remesh this particular component again. Okay, now you can see that the meshing has been completed and the stage moved to the filling stage. Yeah, with this, let this particular filling process get completed. In the meanwhile, I'll just showcase you how you can specify the core utilization as well. Now, this particular analysis is running with 4 cores. So you can just go to the preferences over here and you can specify how much cores it used to take to run this analysis. More number of cores you provided, you can run this particular simulation in the faster part. So, and also you can specify different types of visualization. So let me just showcase you. Yeah, so when you go to the analysis, you can specify the SMP CPU threads or the MPI. If you are using servers, you can specify the MPI CPU cores for your analysis to run. Now here you can see that number of cores it is utilizing is 4. So I have 6 cores in this particular machine. So I'm utilizing all 4 cores to run this particular simulations. You can make it 8, 10 depending on the cores available in your machine. Then also you can specify what type of visualizations you want, how your results needs to be available. You can specify it here, and how your numbering should be there, whether it should be mixed or the results should be in terms of e raised to 4 or those formats. You can specify it here. Okay. Now you can also specify the video capturing. So you can specify what type of file format you want, what is your frame rate. You can specify for the capturing of the images also and where it needs to be saved. So all these options are available in this particular preferences where you can select as per your requirement. Oh, sorry. Looks like since I clicked on the OK option with preferences, it actually crashed my model. Give me a minute. I'll just redo the parameters for you. Now you can see that the filling time is almost reached 43%. So another 2 to 3 minutes and the analysis will be completed. Yeah, now I can see that the filling process is completed and the solidification process has been started. Yeah, now I can see that the process has been completed. Now I can select this particular component and you can just click on the view now, and this will take you to the result page. Okay, where you have the animation of how the particular molten metal is flowing into the liquid under the gravity. Okay, and you have different result types. Now you can see all the three stages: fillings, solidification, and also demolding. You can see all the stages here, and in the results you can check for the temperature, which is nothing but how the temperature changes during the filling process. So here in this you can determine this temperature required for the different fronts of the material to fuse and study the risk of the molding. Okay, next you have is the flow front, where you can this cold front will help you to observe how the material behaves as it enters the mold, so that you can predict a filling time with this. Okay, the next one you have is gate contribution, how much how this particular gate is contributing in the filling processes. Okay, and next one is the solid fraction. So solid fraction is nothing but it's a display areas where the solidification occurs. Here these multicolored areas will not fill completely and are therefore prone to shortage of the material. So based on these results, you may need to increase the pressure, increase the velocity, or reduce the filling time to prevent shortage of the material. So in this particular, this wherever the red color represents the liquid material, where there is no filling issues. So wherever you find these blue green kind of things, there are certain filling issues. Since filling issues, so you can either change the orientation of this particular ingot, or you can just provide some risers or chillers to help the flow of the particular molten metal into the mold cavity in a smooth variations. Then next we have is the velocity, how fast this particular metal flows into this particular component. It will show you either by vector format or by your component. Okay. Next we have the last air, which is nothing but the air entrapped when the molten metal is flowed into this particular cavity. Whatever the air available in this small cavity will be pushed towards the extreme end of the cavity, and this will create a porosity or any kind of shrinkage in the material. So to avoid this, either you can provide a riser or overflow so that the air available in the particular mold cavity can be moved out of the region. Similarly, we have the mold erosion, in which and all locations the mold is eroded, the pressures, how much filling time will help you to understand which and all parts are filled faster. Okay. Similarly, we have it for the solidifications, where you can see the temperature, how fast particular the temperature moves to the cold once after the liquid is flowed into the mold cavity. So likewise, you can detect all these parameters, and you also have a record session where you can record this particular session, how this particular component behaves and when the molten metal is flowing, and these recordings can be utilized for your reporting purposes. Okay, so this is how the gravity casting is carried out in this particular model. So let's move on to the creation of low pressure die casting. So for which, let me just grab a model for low pressure. Okay. Now I have this particular wheel ring, alloy wheel, where high finish, good quality casting is required. So here, what the first option, as I showed you, is a simple 5-step process. You can select the particular component, specify the material properties, specify the temperatures, then you can specify how the which is the gravity directions, you can specify it. Okay, then you can specify which is your ingate. Okay, I'll specify this is my ingate, so I'll create one ingate. And then in the component, since it is a low pressure die casting, I have to have a stock where the molten liquid flows into this particular mold quality in a smoother smoother variations. So I can create a stock either from this particular component window, okay, or I can directly create it in a basic setup when I am selecting the process, low pressure die casting process. So here you can specify the stock dimensions, stock height and the thicknesses. I can specify it. You can specify what it is an isothermal or exothermal process. I can specify the temperature of the stock. Okay. Once this is done, can directly go to the low pressure casting, where I need to specify what are the time frames required to run this particular analysis. So I'll say for 1 second, the pressure with which the molten liquid needs to be flowed is around 100 MPa. The second one, I'll keep it as for 3 seconds the pressure needs to be increased to 200. Then I'll make it here 5, for which I'll keep 220. Pressure needs to be at 7 seconds. This needs to be increased to I'll say 240. Specify this particular pressure parameters. Once I specify the pressure parameters for the flow, I can just click on the run. Okay, sorry, I need to run this. So here you can specify both the parameters. You want to have the faster results, you can provide the element size here maybe as 10, and then you can run the simulation. So since I already have this particular analysis will take a bit higher time, I have already have the results available with me. So I'll open those results. So I have this particular model which is already run. I'll directly go to the result view. Okay. Now, so now you can see here how this particular low pressure die casting works. Slowly it was 100, then moved it to 200, 240, 260 pressure, and you can see how the molten metal is filling into the particular casted die cavity. Yes. Uh, yeah, one more thing. And if you want to create any mold cavity, I'll just stop this. Yeah, if you want to create a mold cavity for this particular component, you can directly go to the components option. We have the mold option here. You can create a mold cavity. You can specify what is the mold is created of, its dimensions. Okay. Next, if you want to create a chiller or a cooler, so you can specify the cooler. Select the space. So, a minute. Yeah, I'll select this region. So I'll create a cooling pipe where the water is flowing. Okay. I can specify what material it is flowing here. So I'll say water. I'll create a cooling cooler. And this particular cooler can be moved to any location by using the manipulator. So simple and easy to use. So yeah, so let me just take it back over here. And here you can also see how the temperature, cold, same type of results are available. You can visualize it and do changes to your cavity before you can send it to the mass productions. So yeah, so this is all about Inspire Cast. So I'll stop the sharing now, and if you have any queries, feel free to ask.